Utilization of machine learning in screening for multi-drug resistance, presumptive Mycobacterium tuberculosis. My name is Jean Amkwase, and this is the research topic I'll be talking about. So, multi-drug resistance is TB occurs when someone is resistant against the two major drugs that are administered for tuberculosis treatment, which is isoniazid and rifampicin. So multi-drug resistance TB comes up when a patient is resistant against these two drugs. So my research seeks to predict such a case, someone who is resistant against isoniazid and rifampicin, and that person is called a multi-drug resistant TB case. So the problem statement is identification of new and potential cases of MDR TB in Uganda and Africa at large is still a serious problem, and development of TB, which eventually actually also leads into multi-drug resistant TB case, results into more infections in the communities, as we all know that TB is contagious. And these also are coupled with severe side effects from the drugs and increased poverty, because when you are resistant to rifampicin and isoniazid, the side effects from the drugs when they are still administered to you, yet you are an MDR TB case, and also increased poverty because the costs of those drugs is not cheap. Then also increased treatment period of up to even 18 months when someone is resistant against isoniazid and rifampicin, but the doctors are not in the know. Someone can receive treatment for up to 8 months and there is no change, there is no cure, there is no positive feedback, yet they and they are a TB case. So our main objective is to develop a machine learning model to predict MDR TB occurrence in a patient. And the key specific objectives are: one, to identify the patient level characteristics that contribute to MDR TB, to also apply machine learning classification algorithms to view, train, and test the predictive model that will be developed, to also evaluate the performance of the models and select the best performing model, and then finally to develop a prototype, which is a graphical user interface capable of communicating the model to the domain users for its effective utilization. Our scope of study was not only Uganda, but South Africa, Nigeria, and Peru, which according to the dataset provide some level of diversity in topic and the study. However, much TB is prevalent in other countries and continents, not necessarily these ones. So our research is only confined to the prediction of MDR TB in suspected patient cases, and it does not cover screening for the presence of TB in the respiratory tracts of suspected cases, and neither does it also cover the confirmatory tests needed to confirm or rule out presence or absence of multi-drug resistant in TB suspect and confirmed cases. The current technology that exists confirms presence of MDR TB is a TB DNA PCR test, which is in Uganda and is mostly performed using the TB Gen Expert machines. So the significance of this study, we hope it will be of value to the research community, to the physicians, and also the industry at large. Literature review: TB is caused by bacteria, which is known as Mycobacterium tuberculosis, and is actually curable and preventable disease that most often affects the lungs. It is spread from person to person through air, and when people with lung TB cough, sneeze or spit, they propel the TB germs into the air. So a person needs to inhale only a few of these germs to become infected with TB. Multi-drug resistant TB, this is the bacteria that causes TB, can develop resistance to the antimicrobial drugs, which are isoniazid and rifampicin, and they're used to treat the TB disease. So MDR TB is TB that does not respond to at least those two, isoniazid and rifampicin, which are the two most powerful anti-TB drugs. So our methodology, one key thing, we are using machine learning. Those are binary classification algorithms, and the key tools Python, Jupyter notebooks, spreadsheets, and SQL. And then the classifiers, one, during data exploration, we tried logistic regression, support vector machines, and random forests. But the best classifier is logistic regression, and that's what we went ahead with because it had the best accuracy of 96%. And then also it had a less mean squared error. It had a great precision and recall score, and a great value for the area under curve. So that's why we chose logistic regression amongst the other three classification models. Yeah, for validation actually improved the accuracy of the model by using K cross validation, because initially it was at 95 and it improved to 96 when we validated the work. For evaluation, that was using area under curve and the confusion matrix. And this also contributed to the great increase of the accuracy levels. And then after development of the model, it was deployed onto a graphical user interface where doctors can communicate and get a result of an MDR TB case. So the key attributes from the model are what you are seeing on the screen. So this is the user interface, and the key attributes that were in our data collection were: one was age, sex, marital status, poverty level, prison history, completed secondary school, history of tobacco use, alcohol use at least once per week, history of drug use, history of being in a rehab, your body mass index, which is basically if you're underweight, normal weight, or overweight, then the history of chronic disease, your HIV status, and then history of diabetes mellitus, and finally your TB treatment outcome. So these were our key 16 features, but through model and data exploration, the key features that have a great impact to the target value, which is the MDR TB case, is one was treatment outcome. Then the next was the history of drug use, your alcohol use at least once per week, your history of tobacco use. And then the other was to do with the HIV status, then marital status, and then age and sex were the last. So basically now for one to predict an MDR TB case, these are the key attributes one can use, and so we can try to fill in information and see the end result. So if my age is maybe 22 to 26 and I'm female, marital status I'm single, and then poverty, I'm not in poverty. Yes, I've been in prison. I've not completed secondary school. I used to smoke, or I currently smoke. So this is mostly your history of tobacco use. If you used to smoke, or if you've never smoked, or you currently smoke, your alcohol use at least once per week. Yes, I do drink. History of drug use. Yes, maybe I'm on drugs. So history of rehab, definitely if you've been on drugs. From the correlation matrix, these two were correlated. The history of drug use and history of rehab were correlated. So these can be matched and we come up with one attribute. Then also the body mass index, maybe I'm normal weight. History of a chronic disease, maybe yes, I had one. HIV status, maybe it was not done or it's unknown. Then history of diabetes mellitus, no. Then the treatment outcome, maybe someone is still on follow-up. So these key features, already one is a TB case, but what we are predicting is their resistance against the two major powerful drugs that are used for TB treatment, which is isoniazid and rifampicin. So already someone is a TB case, but we are predicting them being resistant against the two major drugs. So when we submit this, we should be able to get a result, and this person is now an MDR TB. They are classified as an MDR TB case. So this person is going to be resistant against rifampicin and isoniazid. So this is basically it for future research. Like I said initially, in a scope, this does not cover screening of TB. It does not cover further now treatment of if now you're resistant against rifampicin and isoniazid. What are the key steps to take? So in our future research, those are the key areas. We hope to add diagnosis already. Now, yes, I know I'm an MDR TB case. What next? So this is basically our next research or in our future work. Yeah, thank you. That's it.